Assalamualaikum warahmatullahi wabarakatuh. We are from 8th group. Here we are going to present our portfolio about Reboiler. 8th group consists of Muhammad Irfai, Rania Sekar, Mi Farhadia, Rinanda, Ayani Putri, and Diva Atmarita. The first point is abstract. So in this portfolio, we are going to explain about Reboiler, especially horizontal thermosiphon, and we are going to measure and analyze whether the design is suitable or satisfy the case by using 1 through horizontal thermosiphon for heating 60 API naphtha, using 28 API gas oil, and we also calculate the dirt factor that will be 0.0024.
Okay, next is introduction. I'll explain first about the reboilers. Reboilers are used to evaporate some of the bottom products in distillation columns. And reboilers is categorized into 3 types of reboilers. First is forced flow reboilers. Second is thermosiphon reboilers, and third is kettle reboilers. Next. Okay, here is the strength and weakness of each type of reboilers. The first forced flow reboilers, the strength is suitable for low vacuum operation and for low rate of vaporization and can be used for high viscosity. But the weakness is pump is required, high cost and danger of leakage. The thermosiphon reboilers, the strength is the most economical and can be used for high vaporization. But weakness is column base must be elevated to provide the hydrostatic heat required and not suitable for high viscosity fluid or high vacuum operation. And the last is kettle reboiler. The strength is suitable for vacuum operation, suitable for high rate of vaporization and easy to maintain. But the weakness is not suitable for falling materials and larger cell needed. Okay, here is the study case about one-stroke horizontal thermosiphon reboiler. One-stroke horizontal thermosiphon reboiler will be used to heating 38 and 500 pounds per hour liquid 60 API naphtha by using 28 API gas oil and produce 29,000 pounds per hour vapor.
So the next one is methodology. The first one is here's the flow chart to solve the case study. Next.
Okay, for the solving case study, first we have to estimate the specification of reboiler, then we have to form the cell side and also the tube side, and the second one is calculate the heat balance, and then find the delta T, and the fourth method is find the TC.
And for the step 5 is find AT, which is by NT multiplied by AT and divided by 144. And the sixth step is find the GT by W divided by AT. And the seventh step is find Reynolds numbers, where we can see that the viscosity value of 1.06 lb per feet hour and the diameter is 0.0695 feet. So we get the Reynolds number is 59,200. The eighth step is find GH. From appendix table 24, we get the value of GH is equal to 168. And step 9 is find K multiplied by C viscosity divided by K to the power of 1 per 3. From figure 16 on appendix, when the DC is equal to 451 Fahrenheit, we get the value of 0.142 BTO per hour feet power of 2. And for the step 10 is we going to calculate the sigma T, and we got the sigma T value is 1. And the Next step is calculate HEO. Uh, we got the HEO by multiple the HI with ID divided by OD, and we get the value of 286 BTO per hour feet quadrat Fahrenheit. And the step 12, we're doing the other assume for cold fluid, which is shell side and naphtha. Next step is for calculate the overall clean coefficient, which is EUC, and we get the value of 116.
And then we calculate the Desain overall coefficient, and then we calculate the dirt factor, and we get it is 0.0024. Then this is the summary from our calculation. The dirt factor is somewhat low for continued service. The higher pressure drop on the gas oil line is insignificant, and now that the design is satisfactory.
Okay, for the conclusion, next. That from the picture there is horizontal thermosiphon reboiler that we get that the dirt factor is somewhat low for continuous service. The high pressure drop on the gas oil line is insignificant. When a reboiler is over designed, it may operate by breathing. As liquid enter the reboilers, it may be completely vaporized very quickly because of the over design. So no new liquid replaces and cools the surface down. The new liquid remains in the reboiler momentarily and is heated and completely vaporized also, so that the intermittent burst of vapor issue from the reboiler outlet instead of a smooth continuous flow of vapor and liquid mixture. So this can be overcome by reducing the pressure on the steam if steam is the heating medium on by placing an orifice on the shell outlet plane so as to cause an increased pressure drop on the vapor.
Okay, so in this portfolio, the design used is a one-stroke horizontal thermosiphon reboiler, which will be used heating 338,500 pound per hour liquid, and in the temperature range, which stated in the slide, and we can see the figure of isometrical horizontal thermosiphon reboiler below. Next. Okay, so that's all from our presentation. Wassalamualaikum warahmatullahi wabarakatuh.